The National Electrical Code, or NEC, does not specifically mandate a bonding grid for above-ground pools. However, the NEC stipulates that all metallic components of an above-ground pool must be electrically bonded together and connected to the electrical system grounding. This encompasses the pool wall itself, any ladders attached to the pool pump, and any other metallic parts associated with the pool structure. The bonding must be implemented using a number 8 American wire gauge, or AUG, solid copper conductor. The connection of the conductor to the pool wall should be achieved using a designated bonding lug to ensure a secure and reliable electrical connection. The opposite end of this conductor must then be connected to the grounding or bonding lug located on the pool pump. In scenarios where the pool pump lacks a grounding or bonding lug, the conductor should instead be connected directly to the service panel ground or neutral point. The fundamental purpose of this bonding procedure is to equalize the electrical potential across all metallic parts of the pool. This measure is crucial in mitigating the risk of electrical shock by ensuring that no significant voltage difference exists between different metallic elements that a person might come into contact with while in or around a pool. To further clarify the requirements and best practices for above-ground pool bonding, let's delve into some specific aspects and considerations. Firstly, the selection of the correct bonding lug is paramount. The lug must be corrosion-resistant and specifically designed for direct burial or immersion in the pool environment. This ensures longevity and prevents the connection from degrading over time due to exposure to moisture and chemicals. Secondly, the number 8 AWG solid copper conductor should be installed in a continuous run without any splices. Splices can introduce points of high resistance, which can compromise the effectiveness of the bonding system. If a continuous run is not feasible, use only approved splicing methods that are designed for direct burial and provide a reliable, low-resistance connection. Thirdly, when connecting the conductor to the service panel ground or neutral, ensure that the connection is made in accordance with the NEC requirements. This typically involves connecting to the grounding busbar within the service panel. Make sure that the connection is secure and that all hardware is properly tightened. Fourthly, it is important to consider the location of the bonding connections. The connections should be readily accessible for inspection and maintenance. They should also be protected from physical damage and exposure to harsh chemicals. Fifthly, the NEC provides specific requirements for the grounding and bonding of electrical equipment in and around pools. These requirements are intended to minimize the risk of electrical shock and ensure the safe operation of the pool equipment. It is essential to consult the NEC and local codes to ensure that all electrical work is performed in compliance with these requirements. Sixthly, in addition to the bonding requirements, the NEC also requires the installation of ground fault circuit interrupters, or GFCIs, for all electrical circuits serving the pool equipment. GFCIs are designed to detect small amounts of current leakage and quickly interrupt the circuit, preventing electrical shock. Seventhly, regular inspection and maintenance of the bonding system are crucial to ensure its continued effectiveness. Check the connections for corrosion and tightness and replace any damaged or deteriorated components. Eighthly, it is always recommended to consult with a qualified electrician to ensure that the pool bonding system is properly installed and meets all applicable codes and regulations. A qualified electrician has the expertise and knowledge to perform the work safely and correctly. Ninthly, when dealing with electrical systems, safety should always be the top priority. Always disconnect power before working on any electrical equipment, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Tenthly, consider the impact of the surrounding environment on the bonding system. Factors such as soil conditions, water chemistry, and proximity to other metal structures can all affect the performance of the bonding system. Take these factors into account when designing and installing the bonding system. 11thly, remember that the purpose of the bonding system is to create an equipotential plane, which means that all metal parts of the pool are at the same electrical potential. This minimizes the risk of electrical shock by preventing voltage differences between different metal parts that a person might come into contact with. 12thly, be aware of the potential for stray voltage in the pool area. Stray voltage can be caused by faulty wiring, improperly grounded equipment, or other electrical problems. If you suspect stray voltage, contact a qualified electrician immediately. 13thly, the NEC provides detailed requirements for the installation of wiring and equipment in and around pools. These requirements are intended to minimize the risk of electrical shock and ensure the safe operation of the pool. 14thly, the bonding requirements for above-ground pools are similar to those for in-ground pools, but there are some differences. It is important to understand the specific requirements for your type of pool. 15thly, the NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. Consult the latest edition of the NEC for the most current information. 16thly, the bonding system is just one part of a comprehensive electrical safety plan for your pool. Other important components include grounding, GFCI protection, and proper wiring practices. 17thly, the use of non-metallic conduit and enclosures can help to reduce the risk of electrical shock. Non-metallic materials are not conductive, so they cannot become energized. 18thly, consider the use of a pool cover to help prevent accidental contact with electrical equipment. A pool cover can also help to reduce evaporation and keep the pool clean. 19thly, educate yourself and your family about electrical safety around the pool. Make sure everyone knows how to recognize and avoid electrical hazards. 20thly, remember that electrical safety is an ongoing process. Regularly inspect and maintain your pool electrical system to ensure that it is in good working order and meets all applicable codes and regulations. 21stly, when connecting the number 8 AWG solid copper conductor to the pool pump, ensure the pump is properly grounded according to manufacturer's instructions and local electrical codes. This grounding provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. 22ndly, consider the use of listed and labeled products for all electrical connections and equipment used in the pool area. Listed and labeled products have been tested and certified to meet safety standards, providing an extra layer of protection. 23rdly, when running the bonding conductor, avoid sharp bends or kinks that could damage the conductor or compromise its electrical conductivity. Use smooth, gradual bends to maintain the integrity of the conductor. 24thly, regularly check the water chemistry of your pool to ensure that it is within the recommended range. Imbalances in water chemistry can accelerate corrosion of metal parts and compromise the effectiveness of the bonding system. 25thly, be aware of the potential for galvanic corrosion, which can occur when dissimilar metals are in contact with each other in the presence of an electrolyte such as pool water. Use compatible metals or isolation techniques to prevent galvanic corrosion. 26thly, if you are not comfortable working with electrical systems, do not attempt to install or repair the pool bonding system yourself. Hire a qualified electrician to do the work safely and correctly. 27thly, remember that the pool bonding system is designed to protect people from electrical shock. Do not compromise the system in any way, and always follow the NEC requirements and local codes. 28thly, consider the use of a surge protector to protect your pool equipment from voltage spikes and surges. Surge protectors can help to extend the life of your equipment and prevent costly repairs. 29thly, when installing the bonding conductor, ensure that it is properly supported and protected from physical damage. Use conduit or other protective measures to prevent the conductor from being accidentally cut or damaged. 30thly, regularly inspect the pool area for any signs of electrical hazards, such as frayed wires, damaged equipment, or standing water near electrical outlets. If you find any hazards, take immediate action to correct them. 31stly, be aware of the potential for electrical hazards associated with overhead power lines. Maintain a safe distance from overhead power lines when working around a pool. 32ndly, consider the use of a remote control system for your pool equipment. Remote control systems can allow you to operate the equipment from a safe distance, reducing the risk of electrical shock. 33rdly, when installing the bonding conductor, ensure that it is properly connected to all metal parts of the pool, including ladders, handrails, and diving boards. This helps to create an equipotential plane and prevent voltage differences between different metal parts. 34thly, regularly check the operation of the GFCIs in the pool area to ensure that they are functioning properly. GFCIs should be tested monthly to verify that they are able to quickly interrupt the circuit in the event of a ground fault. 35thly, consider the use of a pool safety cover to help prevent accidental immersion. Pool safety covers are designed to support the weight of a person, preventing them from falling into the pool. 36thly, when installing the bonding conductor, ensure that it is properly insulated to prevent accidental contact with other metal objects. Use approved insulating materials that are designed for direct burial or immersion. 37thly, regularly inspect the pool equipment for any signs of wear or damage. Replace any worn or damaged parts promptly to prevent electrical hazards. 38thly, be aware of the potential for electrical hazards associated with portable electrical equipment, such as radios and televisions. Keep portable electrical equipment away from the pool area and do not use it near water. 39thly, consider the use of a pool alarm to alert you to unauthorized entry into the pool area. Pool alarms can help to prevent accidental drowning. 40thly, when installing the bonding conductor, ensure that it is properly grounded to the earth. This provides a path for fault current to return to the source and helps to prevent electrical shock. 41stly, regularly check the water level in the pool to ensure that it is at the proper level. Low water levels can expose electrical components and create a shock hazard. 42ndly, consider the use of a pool fence to restrict access to the pool area. Pool fences can help to prevent accidental drowning, especially for young children. 43rdly, when installing the bonding conductor, ensure that it is properly protected from corrosion. Use corrosion-resistant materials and coatings to prevent the conductor from deteriorating over time. 44thly, regularly inspect the pool lighting to ensure that it is functioning properly and that there are no exposed wires or damaged fixtures. Replace any faulty lighting components promptly. 45thly, be aware of the potential for electrical hazards associated with underwater lighting. Underwater lighting must be properly grounded and GFCI protected to prevent electrical shock. 46thly, consider the use of a pool heater to extend the swimming season. Pool heaters must be properly grounded and bonded to prevent electrical hazards. 47thly, when installing the bonding conductor, ensure that it is properly sized to carry the expected fault current. Consult the NEC and local codes for the appropriate conductor size. 48thly, regularly check the pool skimmer and filter to ensure that they are clean and functioning properly. Clogged skimmers and filters can cause the pump to overheat and create a fire hazard. 49thly, be aware of the potential for electrical hazards associated with pool chemicals. Store pool chemicals in a safe place and handle them carefully to avoid spills and contamination. 50thly, consider the use of a professional pool service to maintain your pool and ensure that it is safe to use. A professional pool service can inspect your pool equipment, test the water chemistry, and perform any necessary repairs or maintenance.